Okay, here are the work solutions to the second prelim. 1 hour, 40 marks, calculator paper. Start off with this trig curve. We're told that it is of the form y x minus d, and we have been asked to find the value of d. Now, with this being a cosine curve, we would expect it to start at 0. But by studying it, we can see our starting point here has been moved 30 degrees right. So this gives us a value of d equals 30 degrees. 1 mark question to get started on the paper there. Question 2, change of subject. You have been asked to make M the subject, and M over here on the right hand side, trapped inside those brackets. Couple ways you can do this. I would start by rearranging, looking at the 3 on the bottom there. So I would start by multiplying each side of this equation by 3 to give me 3p equals 2 lots of m minus 6. I would then deal with the 2. So the whole of the bracket's been multiplied by 2. So to reverse it, I would divide each side by 2. 3p over 2, leaving it as a fraction, would leave me with just n minus 6 there. Got to get rid of the minus 6. So plus 6 to each side, 3p over 2. Now that is being treated as one term on its own, and I'm adding 6 to that. So it's important that the plus 6 is not part of the initial fraction. All that's left for me to do is tidy it up, having my subject first, 3p over 2 plus 6. Alternative way to solve this would be to get rid of the fraction as before, and there may be some of you that think I could multiply that out by 2, and that's a perfectly valid way to progress. You would be left with getting rid of that minus 12 by plusing 12 to each side of the equation. Then looking and going, well, I need to get rid of the 2 to get the m on its own, to make m the subject. And to show I'm dividing all of that by 2, I could write it as one fraction. Again, subject first. Now that does look slightly different from before, but if you were wanting to write this as 2 separate fractions, you could look 3p divided by 2, well that won't simplify, 3p over 2, and then looking at the second part there, plus 12 over 2, well that would give me plus 6, which was the same solution as we had the first method. Third question, I suppose the key word here is the word gradient. We want to calculate the gradient of a line. Straight away, I would be writing down the correct gradient formula. M equals y2 minus y1 over x2 minus x1. And I would be jotting down my two coordinates. Now, the key to this question is not to get worried about the fact that we've got algebraic terms. I would label them x1, y1, x2, y2, same as I would with any question like this, just so I know that I'm putting the right term into the right place in the formula. So, y2 minus y1. Okay, so just taking my values from my coordinates over x2 minus x1. Now, I suppose the second keyword in this question is, or the key phrase, is this idea of the simplest form. Algebraic fraction, looking at the top, t minus a. There's not much I can do with t minus a, but the bottom should look very familiar. The bottom, t squared minus a squared, that's the difference of two squares. That will factorise to t minus a, t plus a. So it's testing two things in this question. It's testing whether or not you know your gradient formula, and it's also testing your recognition of things that can be factorised. All that's left to do is to simplify it. T minus a on the top can cancel out the t minus a on the bottom. Leave me with, well, dividing the top and bottom by t minus a would leave me with 1 on the top and 1 lot of t plus a on the bottom. So all that's left to do is to write it in its simplest form, 1 over t plus a. If you wished, you could leave that in brackets there, but they're not necessary. A 3D vectors question next. So we've got two forces acting on a rocket. Were represented by vector A and vector B. And then it says to calculate the magnitude of A plus B. It also says to leave your answer as a surd in its simplest form. So, the resultant vector, A plus B, is just a case of taking your two vectors and adding the components together. So you would get your first mark for adding first components. Now being careful with your negative numbers, 5 plus 3, plus negative 5 would be negative 2. Second component, 7 and the minus 1. So just taking care with those, 7 plus minus 1 would be 6. And third component, on down the bottom, minus 6, positive 8, positive 2. So no different from dealing with a 2D vector. Find the magnitude of the resultant vector. We're essentially just applying Pythagoras. So I need to take the first component and square it. Add the second component squared, and add the third component squared. And I'm taking the square root of all of that. So negative 2 squared would give me 4, plus 6 squared would be 36, plus 2 squared would be 4. Tidying that up gives me square root of 44. All that's left to do is to actually answer the question. We've been asked to write the vector in its simplest form. So looking at this, I need to think in terms of square numbers. 4 times 11 gives me 44. So root 4 times root 11 would give me the square root of 44. Simplifying that to root 11. Third question, trig equation. Solve the equation 5 tan x minus 6 equals 2. And we're interested in solutions between 0 and 360. So, just like any sort of equation, you would try to get the variable, you would try to get the x on its own. So I would start by adding 6 to each side. So 2 plus my 6 gives me my 8. I would then need to get rid of that 5. So to get tan x on its own, I would divide by 5. Now, the first step here is to find the acute angle I'm dealing with. I know tan of x equals 8 over 5, so I'm going to find the inverse tan of 8 over 5. So, typing that into my calculator gives, rounding to one decimal place, 58.0. Now, the whole point in this is the trig equations generate more than one solution. A variety of ways to get your solutions. The way we would be encouraging you to do it is to use your ASTC diagram. But remembering our 3 quadrants, we've got our first quadrant between 0 and 90, where all functions are positive. Between 90 and 180, where just the sine function is positive. The tangent function is positive between 180 and 270, and cosine is positive between 270 and 360. Now, if we look back to our original equation, we can see tan x is positive. So this helps us identify the quadrants we're working in. We know our solution is positive, so all things are positive in the first quadrant. Solutions to tangent equations are positive in the third quadrant. So our first quadrant answer is just our acute angle. In the third quadrant, well, we need to remember that this is 180 and I need to go forwards. I need to add on my acute angle. So 180 plus 58.0 gives me 238. 238.0 degrees. So, two separate solutions. An alternative method for this would involve drawing the trig graph for tan x, and using symmetry to see where it has the repeated value of 5 over 8. But this method a lot more straightforward, especially in terms of drawing the tan curve. Quadratics problem. The diagram shows part of the graph y equals 4x squared plus 4x minus 3. The graph cuts the y-axis at A, and it cuts the x-axis at B and C. Write down the coordinates of A. So, A is the y-intercept. That occurs when x equals 0. So I can take that and plug it into my original equation. 4 lots of 0 squared plus 4 times 0 minus 3. 0 plus 0 minus 3, which is just negative 3. It says to write down the coordinates of A, so make sure, if you're being asked that, to write it as an actual coordinate with x coordinate of 0, y coordinate of minus 3. In terms of exam technique, I suppose one word here to pay attention to is to write down. So really, there's no need for me to go through all those calculations. If I look at the original equation, it states minus 3 as a constant on its own there. So I can read that off as my y-intercept. Find the coordinates of B and C. Those are my roots. A number of ways you can find those. By and far the easiest method, I would say, is to take your quadratic equation, set it equal to 0, and factorise it. Now, need to take care here. 4 times minus 3. So I'm using the magic number method. So I'm looking for numbers that multiply to give me negative 12, that add up to give me positive 4. Again, I'd be encouraging you to write down pairs of factors in an organised way. Studying this to get positive 4, well, 1 and 12 won't work. Negative 2 plus 6, so let's check. Those two multiply to give me negative 12, and they add up to give me positive 4. So, I can start factorising this. 4x squared, and I can replace the plus 4 with minus 2x plus 6x, and the minus 3 remains unchanged at the end there. I look at my first pair of terms. I can see 2x as a common factor. 2x times 2x would give me 4x squared. 2x times minus 1 would give me minus 2x. Same for the second pair. Again, positive 3 for a common factor, which would leave me with 2x minus 1 for my second bracket. Just a quick check, my two brackets are the same, so that means I've factorised this correctly. 2x minus 1, taking out the bracket as a common factor, and I'd be left with 2x plus 3. Need to remember to put in equals 0 for each line. To solve this, 2x minus 1, so this factor would equal 0. So that would give me 2x equals 1. So x would equal a half. Second factor, 2x plus 3, also equals 0. So I work through this mini equation to get x equals minus 3 over 2. It asks me to write down the coordinates of B and C, so I just need to take care. B is the one back here, so that's the one with the negative x coordinate. So B has to be negative 3 over 2, 0. And C would be the second of the two, the one with the positive x coordinate. So that would be a half, 0. The diagram we've got originally here isn't to scale, but I can see C is closer to the 0 than B, which makes sense in terms of the fact that a half is less than 3 halves. Right, third and final part, calculate the minimum value of the function. Essentially, it's asking you about the turning point, the lowest place on the curve. What is the minimum value? So we have to go through this carefully. I need to find the x coordinate. A lot of people seem to get muddled when finding this. They're unsure, do I add or take away the two x coordinates of the roots? You would add, you're finding the mean, the average of the two. Another way is just to sort of use a bit of common sense. I'm looking for the middle point of minus 3 and 1. Minus 3, 1. I can see there the middle of it's going to be x equals 1. So I need to take x equals minus 1, the